Hello, guys. Welcome to another meetup. Samir, you are muted. It's fine. Okay. Yeah, up to you. I mean, just usually I can see you and Ty. Yeah, feel free to show or mute. Up to you.
Yeah, I'm not in a position to show my face today, but I'll just listen.
Okay, that's fine. Just fine. So welcome again. I think this week, as I talked about in the Slack channel, we're going to talk about a series of articles and a new way of writing a smart contract such that you can import the blockchain data into the smart contract. The amazing thing, the surprising thing here, you can do this without any oracle and still maintaining a very high integrity or confidence about the data you are employing. So I think I sent a few articles to be just 4 exactly. So I hope you guys have seen at least some of them. And first, I think I will just go over them in high level. And then you guys can, if you have any questions, just feel free to interrupt me anytime. And then afterwards, we can, basically, I want to brainstorm with you guys. I mean, these are all building blocks, right? For example, you can access some block, you can access the height of the block, you can even know how many transactions this block has, but then how do you use it in all kind of innovative ways in your contract? So that's the basic outline we're going to go today. So if there's no further question, I will share my screen and get started. Any comments so far? Or you good?
Nope, go for it.
Okay, man. All right, you guys see my screen okay?
Yep.
Okay, great. So this is our official blog. So if you don't know how to get here, just always go to our official website, sCrypt.io. So if you just click all the way to the bottom, you click the medium one, that will take you here. So let's look at a few, basically a series of 4 articles we released this week. So I will start with the first one, access blockchain data from Bitcoin smart contract without oracles. So yeah, another way is almost if we are doing SPV, but on chain in script. So for people who know about the SPV, so usually you have block headers, right? After block headers, you want to verify some transactions that's in certain blocks. So you use the Merkle proof, and then you can you just only need a very short amount of data. Then you can verify this without download the whole blockchain. So we are kind of doing similar things here, but it's down on chain in script. So the typical way, the blockchain, right? Smart contracts we know before, it doesn't have an interface to the outside world. It's almost like a sandbox. It's its own virtual environment. So you can almost think about it as like a calculator, right? It doesn't have. I think last week we talked about it doesn't have this op truth, right? Or op weather, right? So we cannot just get any data just from inside this black box. So the way usually it works is, in order to import external data into the smart contract black box, you need to trust some kind of like a third party. Usually we call it oracle, right? You can either use one oracle or you can use multiple oracles. It depends on how much trust you want to place on them and how much coin is in the stake, right? So here we introduce a way that you can get this data, external data, but without such oracles. This is a huge breakthrough actually. So you cannot get this for any arbitrary data, for example, weather. Right? There's no way, if there's no oracle, it's impossible to get it. But that's an exception. So if the data is on the blockchain we're talking about, then it's a very special case. So it's still external to the contract I'm running. It's still considered external data, but we have a way without oracle, you can import it. So how do we do it? I think the building block we have to talk about first. I mean, no pun intended, but it's actually look at the block, right? It's kind of building block here. So as we all know, it's a blockchain, right? So the chain of blocks, and each block has this, at the beginning of each block, we have this structure called a block header. So block header is almost like a meta information about the whole block, for example, right? What this is the specific format the block is in. So for example, you can have a version, you have the block hash for the previous block, you can have a Merkle root for all the transactions that's formed into a Merkle tree here. You can have a timestamp, you can have difficult target, and also nonce. I think I'm not going to talk about all the details here. As we use some of them in the later articles, I will talk to them if we meet them again. So the basic idea is, the most important idea here is, so if I give you just give you a block header, right? How do you know with high confidence it's real? It's actually from the blockchain. It's not just some block header. I just fill in all these 6 fields, and then I just generated locally in my laptop. How do you know that is the case? So because we are using proof of work, so sorry about the proof of stake. You cannot do this in proof of stake actually, because proof of work is like you're almost I like this analogy. It's like, for example, there's a, for whatever reason, the whole world blows up, right? And you are in some underground bunker, and then you want to tell somebody just give you some header, right? How do you know with very high confidence this block header is actually valid? You have no outside knowledge. This is similar to the smart contract we are in, right? You are in underground bunker. You don't have cellular coverage. You don't have internet. You cannot communicate with the outside world. How do you know in this case, with high confidence, this block header, if somebody hands you like in a piece of paper, how do you know this header is legit? So thankfully, because it's a proof. Go ahead.
I was gonna say that isn't it supposed to work with the wallet software where everybody like stores the chain of the some sort of block header hash of the block headers with SPV? So every wallet would have, I guess, since the last time they connected to the internet. So if you're in the underground bunker, it wouldn't be completely up to date, but at least you'd have some amount of history, and then you could check if it's in your local store.
But what about the future blocks? You have been disconnected for a year, right? So that's a nuclear winter outside.
Oh, I see.
For example, right? This is basically the way you think about smart contract. That's what it knows, right? It doesn't know outside world at all. It doesn't know the chain of headers. I mean, you can push to a certain degree. We're going to talk in the next article, but you can think of it in this basic case. You're just in an underground bunker. You have no external. Okay, David. Okay, David is joining. Schema.
How do I see everybody? I could just see like the few people at the bottom, but I can't see the whole list.
Oh, you can also. I think maybe there's a view. Let me.
I don't know. It's all right.
Yeah,
It's
I think when we get rid of the. Let's see. It's better. Yeah.
It's okay.
Okay.
Maybe it's because I'm on my iPad or something. I don't know.
Okay. Yeah. Don't worry about too much about it. So the way so if you're in the underground bunker, you don't know any outside information. How do you verify this? So thankfully, the way is you can tell with high confidence with the header itself. Because why? The proof of work, when you hash the block header, you have to generate many leading zeros, right? So this is how the proof of work works. So basically, even I give you, it's almost like a asymmetry it's almost a public key, private key, right? It's very easy to check, but it's very hard to produce such a block header. So if I give you a block header, simply I can just, I can serialize, I can put all this field together and then hash them. I will look at the leading zeros. If there's a lot of leading zeros, let's say 100 or even 120 or 150, I don't know the current block difficulty on mainnet. But let's suppose it's 100 zeros. If somebody give you a header with only like 2 zeros, you're probably not going to trust it, right? But if somebody give you 100 zeros, it's very difficult to produce, and it costs actually a lot of money. So in that sense, you cannot ever be perfect, but everything is like an economic, right? The security is derived, it's like a Bitcoin system is derived from economics. So for example, let's say I use a contract, I trust this header is legit, and I'm betting with some, okay, Jack. A lot of people here today, good. Hello, guys, Jack, David, welcome to join. We're just talking about how do we verify a blockchain header is legit. Hi, Jack. Okay.
Don't let me interrupt.
Okay, I'll keep going, but feel free to interrupt me anytime. So we are talking about, for people who just joined, we are talking about the series of articles we released today, this week. So basically talk about how to access the blockchain, the whole blockchain data without trusting any third-party oracles. So here, we're basing the building block, I mean, no pun intended, is a block header, the block. So if somebody give me a block header, if I hash it, if I find like a very long leading zeros, so I have very high confidence, this is a real. And as I said again in the article also, is possible, you can fake it, right? If you don't worry about the cost, but if you make sure, always make sure, if I trust this, this header is legit, and I'm based on this assumption to lock up some coins, let's say 1 Bitcoin. So if it takes 6 Bitcoins to produce this fake block header, it doesn't make rational sense for attacker to steal my coin, right? It's essentially, it's burning like 6 Bitcoins to produce this header to steal my 1 Bitcoin. Again, it's like back to the security of the Bitcoin system. It's always economic. So this is a big assumption here, which is mostly holds in practice. Unless some guy just want to attack you for no reason, he just want to burn his money, but usually that's not the case, right? So once we have this as a foundation, we can get the block headers. Like we are using I think again, you can see the code, the sCrypt code here. We also publish all the code. If you want to play around, you can also play around. Once we have the block header, we can use SPV, right? For people who don't know SPV, basically the block header contains a field called the root of the Merkle tree, consisting of all the transactions in this block. So if you just want to verify, hello, David. If you want to just verify certain transactions in it, you can just put the much shorter version of a Merkle path, and then you can check it. So in this sense, once you have block header, you can get any transaction you want to access as well. So I put here using one example, right? So basically using the blockchain to generate some random numbers. So the way to do it is you put this contract, the following contract, into a transaction, and then you broadcast it. So usually when you don't know who's going to mine the next block, and also you're probably not going to guess which nonce, right? So here we have a field in the block header called nonce. So basically this is like a random number. The miners keep incrementing until it hits some difficulty target. So we use this field as like a source of entropy here. So basically the idea is you put this contract in a transaction, you broadcast it, and whoever mines the next block, you're going to check the nonce in the next block, which in a more very practical sense is random, right? So you can use this as a random number, or you can use it as a seed for your own pseudo random number generator. You can generate your own random number, and then based on this random number, you can do all kinds of things, right? For example, here I just use the simplest example. So Alice and Bob, right? They're betting. They each lock up 1 Bitcoin. So they're saying if the block that's mined this transaction containing this contract, if it's the nonce ends is even, Alice wins. Otherwise, if it's odd, the Bob wins, right? So this is just a simple case. I think once you have random number generator on chain, that with very high trust, You can do tons of other things, right? You can do all kinds of games. You can do lottery. You can do a coin throw. You can decide to use it as a primitive for more high level protocols, right? For example, you may even do some kind of like a consensus on top of a proof of work. You can say, oh, I can randomly select some from a set of people or nodes. You can do from a pool. So you can build all kinds of things. This is just one simplest example here. And any questions or comments so far?
I think just the use of the nonce for random data. It's interesting.
Mm-hmm.
A miner could potentially roll the extra nonce and not roll the nonce if they wanted to game that. But I think that what you could do to counter that is to take the hash of the produced header at the end, which has all those leading zeros, and then take the end of it. So not all the zeros at the beginning, but take like the last 8 bytes of that hash, for example. And that's going to be some really, really, really high entropy data because it's the hash of the Merkle root, the previous hash, the nonce, whatever that is, the bits.
Yeah.
And that includes, so you could improve it by perhaps taking advantage of the entropy of the end of that really hard hash to find, because the chances that somebody finds a hash set number 1 has all the leading zeros, but also number 2 also is gamed in some way at the end to try to game the random number, thing, perhaps for the advantage of a miner, would be I think much smaller.
Yes.
So I just thought I would kind of throw that out there.
Yeah. So we can look at the block header format again. So we talk about the nonce, right? Which is like a source of entropy. If you want to add more source of entropy, another way you talk about it here, right? It's Merkle root, right? Because this contains all the transactions, including the extra nonce, right? In the Coinbase. So if when you are like iterating to hashing, you either change this nonce or you are actually essentially changing the Merkle root, right? So you can, if you want to more reliable way for entropy, that's another way, right? You can do, this nonce maybe XOR with this Merkle root, right? This all both like a kind of like a pseudo random. If you have more random list, you can do once you have these two, right? I'm not sure about the other. I think a version, some people also change version too. So, but that's not a reliable way. The Merkle root and nonce is very random. So you can, if you want to add more, as Ty said, very good observation. If you want to more, Merkle root.
I guess rolling the Merkle root would break any ASIC boost that's happening. So they might not want to do that. It might make them have a disadvantage, because if they've done any ASIC boost to try to get the 1 in 4 billion chance of the one thing happening, how they do sometimes on the what is it, 28 to 32 byte of the Merkle root or something. But no, I think that's a good idea to kind of XOR or just combine different fields, or just take the hash, right? Like,
you can share them, right?
Yeah.
You can do like what is that? The MAC, right? You can HMAC, right? You combine this both. You do a HMAC.
Right.
You can do all kinds of things once you have two, right? You basically apply a function. The easiest is XOR. If you want to be a little bit fancier, you can do a HMAC. But I don't know how complex it to do HMAC in script. I have to check. But easiest way, as Craig always says, just XOR is great. So any other comments, thoughts, anything? Otherwise, I'll go to the next one. Okay.
Actually, I do have a question. When you said that you could access any transaction in the blockchain, does that mean like any transaction in the blockchain? Yeah,
because if you have headers, right, you can always, if you have headers, then for any transaction within the block, you can always push the Merkle proof, right? Merkle pass, you can check all the way that is the root matches the Merkle root here, right? Then you are sure. It's like an SPV, right? You are just doing it on chain, like in script, right? It's the same thing here. So you can even look at this graph, right? Once you have block header, it has this true hash. If you want to know any transaction, let's say here 4 transactions. If you want to access any transaction, you can push this in the unlocking script. You also push the Merkle path, right? So in the locking script, basically you can check it. Yeah, if you want to look at some code, yeah, it's yeah, basically.
But this is within the same block of, I'm trying to
Yeah, same block.
understand.
Yeah, same block. So if you want to know a
Okay,
transaction,
so it's not like
have
you
to
can
know.
just go
Go ahead.
continue what you're gonna say. If you want to know a transaction, you have to know.
The block header for the block that contains it, right?
Okay.
So this
You can use
block,
any block
Got
header,
it.
Kevin.
yeah, any
Got
block
it.
header you want to have, yeah. Okay, so if no further comment, I will go to the next. All right, let's go to the next. So this is the part one. So basically you can enable you to access the block header and also the transactions, right? So let's look at the part two. So it's a simple extension right here. If you have one block, it's very natural, right, to extend it to a chain of blocks. So which brings us to the word, right? Blockchain, right? If it's blockchain, you have a chain of blocks that chains after one another. So you can also, instead of access just one block, you can also access, let's say, 3 blocks here. What do? You first check, right? Each one of them is legit, right? Using the technique in part one. And then you do an extra check. You hash the first one, make sure the field, right? Because if you remember in our block header, there's one field. It's like a pointer, right? Points to the previous block by hash. So you can hash the first block. You can check if the previous hash, this field, is the same, matches with the hash, right? You can then the second block is definitely right after the first one. You can do the same for the third and second, right? So then you can push a chain of blocks. So why do you even want to push a chain of blocks? So we talked about last time, right? So you can actually, if you really, it's still possible. It's not usually it's not economic. If you want to put the right difficulty down requirement for each individual block header. But if you want to even increase more confidence, this block is legit. You can require, for example, you want to see this block. You want to know the even higher confidence is real, right? How do you know? You can require, oh, maybe you need to push 6 more blocks after this block, right? It's almost like confirmation when you are buying goods with Bitcoin, right? So when you are, let's say when you buy a coffee, probably you just, the zero confidence is probably good enough, right? But let's say if you're like buying a house or buy a car, right? Very fancy car, you probably want to wait a few blocks piled upon the block that's already mined your transaction, right? So same idea here. One way is to ensure the block UI concern is much more expensive to fake, right? Because I think I haven't done the exact math, but I think if you push n blocks, it should cost you like n times more to produce than producing just a single fake block. Right? So you can chain. In this way, you can access, instead of one individual block, you can have access to a chain of blocks. And then the good thing about this, you can actually you can customize how many number of blocks you want to push after the block you are in, because the more blocks you put in, the more confidence you have, right? The first block is
But
legit.
excuse me, but that's become problematic. I mean, on testnet, they've still got this. I've been running into this problem. Testnet still got small blocks like 10 years ago, but mainnet now has, like 2 gigabyte blocks, even more. So we can't do this anymore.
Oh no, actually you are pushing the block header, right? You are not pushing the blocks. So that's why you can do it. Even it's 2 gigabytes, right? The local pass I think is about 10. The height is about 10, right? 2 is 20, right? So if a gigabyte is 20, it scales a logarithmic thing. That's why the SPV works, even for like a very low power device, right? Same thing here. Do you see what I mean? Is you don't push the whole block.
You're still gonna want to look at individual transactions.
Yes.
I don't get. It's not. I mean, it's not. I don't get. you have to use some new code that we don't even have yet to do any of this. I don't think. You have to, in a business processing, anything useful, you're gonna have to look at the actual data. We can't do it now. Unless you get some other query on some other service, they're gonna have some other, God knows what server to give us the block.
Good thing about
we can't do
what
it
we're
on a node
talking about.
anymore.
So, okay, first of all, you
Uh.
don't need the whole block, right? Do you agree on that? Do you see
Well,
what I mean?
no, I don't agree. I don't agree. I'm trying to do some real work. So
Yes.
I don't want to do just this.
Yes.
I
So
can't
here's
in my
the-
JavaScript. I mean, you're not even talking about, again, you're talking about just the locking script. I mean, the sCrypt part is just the locking script, right?
Yes.
I mean, the
And
fun part,
unlocking
but then
script, yeah.
outside, you've got the code in JavaScript or Golang or whatever.
Yeah, whatever
That's
you're
the hard
writing on
part.
app. Yeah.
Yeah. The
That's
hard part's the outside.
depends.
part.
Depends on application, right? I would suggest a lot of time is at least for now, the difficult part is to figure out the smart contract part of things, not the regular application. Because for that you can do any like developers, they know how to do it, right?
No, we can't do it
mature.
now. Well,
What do you mean?
You can't do it anymore because you can't run a full node. You can't
Yeah,
do
you don't.
anything
That's the whole
anymore,
point
really.
we are talking about here, right? You don't need to run a full node. You
Well,
know
they don't
how
have any
SB
nodes. There's no software now to do it at all. Mainnet. We're waiting. I talked to Shatters at New York.
Dude,
I
yeah,
asked
doing
them
what?
to-
Like, can you be more specific? Doing what?
Well, if you try and do heavy smart contracts like Tokenize does, they still need to look at the full node. And for that, because they do a lot of checks, more than even this. And
yeah, I don't know about
Shatters. I
tokenized.
asked Shatters to, well, I don't agree with any of this. We're dead right now, actually, for doing practical work. You have to wait until they gave a new Java library. I saw that there's a new Java library they published from nChain 2 weeks ago. That thing can kind of give you streaming somehow, gives you the headers. But the thing is, there's no server for that. Like, we'd have to wait till, what do you call it, mempool or somebody or Tal implements that Java code, and then we have to pay for it probably now. Instead of a full node for free, house, we have to pay now probably to get this stuff, because we have to talk to some huge server that's got those huge blocks that can send us just a piece of it over this new Java interface they've got to get a little bit at a time. You can request it. So the whole thing, it doesn't exist. So you can't do anything. You can do testnet, but it's not real. Testnet's got small blocks. Yeah, you can still do it.
Let's say what's on chain doesn't have an API to get block headers. I'm a little bit surprised.
David,
Not enough.
I think we might be
I want
talking
the
about
whole
different
thing.
use
I
cases.
don't know. Well, and the whole
I
thing's a
think you
use
guys are
case.
talking about different use cases.
Well, that's the whole problem. We're talking about something it's only a small piece of the real picture. It's not, what good is this to me? Like, you need the whole thing end to end, and we don't have it anymore.
Yeah,
So
I
they
don't know
pulled the
what's your
rug out from
application.
us. Tokenized. Tokenized.com.
Yeah, we are not.
They
not
do
talking about
very heavy.
tokenized here.
Well, we could know, but they're using sCrypt. You saw that, of course, you know about that.
Yes.
They're mixing sCrypt in when they need it, but they need sCrypt plus a lot more to do real life.
Right, so they need to
contracts for
scan.
corporate work.
So
Yeah.
David,
don't
they
need-
need to scan the chain, and they need to have access to all of the blockchain data and they also need to be confident that certain actions like didn't happen, right? So in order to be aware of, in order to prove the absence of an event, you need to be aware of all events. And so that means that what they need to do is have access and tap in to this very large amount of blockchain data. And you're saying that the only way to be able to access that is if you're running a node, and you're saying that, well, you can't run a node anymore because the blocks have gotten too large and your node won't keep up and it's extremely costly. And the only way to be able to access that data is if you rely on some other server, which somebody might provide at some arbitrary point in the future, if I understand you correctly.
They gave a library. They gave a library to do it but the library just doesn't exist. It's not implemented really. They got the code, but there's no server in real life behind it.
Right.
Nobody's implemented it yet.
Right.
Yeah, and you have to pay for it probably too.
Right.
So
you're a use case that requires analysis of blockchain data would not be very viable. And this solution provides access to, if I want to have a smart contract running, And then inside that smart contract, I want to be able to verify a single transaction from a single block or something like that. Then that's what this can provide. But what it cannot provide is a full solution for
It's
stake
out of
management and
scope.
everything.
Yeah, out of scope for this talk. Do you see what I mean?
Right.
It's an independent issue.
Right.
Well,
I mean,
I wish it was in scope because I need to see the whole, it's to me, talking about this little issue, this little piece, I get it, but
Mhm.
it doesn't help much. It doesn't
Right.
help us. It's interesting, but
Yes, it's a building block, as I said in the very
building
beginning.
block,
It's
but
not
boy,
going
it's a
to,
small building block. Yeah.
yes, but you still need it, right? I'm arguing here.
Right.
It's very
Yeah,
useful.
the random number is good. Random number is still
Mhm.
good. I understand it's a
Okay, that's
critical.
good.
Yeah.
Mhm.
Anyway,
Okay.
but
Yeah,
we
good
have to
question.
go and scream. We're doing this. We have to get together and scream at somebody to get the ball rolling again, because although we have this is great, but there's a bigger
Mhm.
picture at the same
Yes.
time, two things at
Mhm.
once. Okay,
Yeah,
so,
very good topic for next week then. Okay.
all right, great. Yeah. All right.
Yeah,
Be there.
you can you, yeah, maybe next week you can just propose what you think there's some existing problem, and then we can discuss how to address them. How does that sound?
Yeah, I like to go through that library, the Java library, and have people look at that and just kind of think
Yeah.
what they can do with it.
Yeah, send
That's the
in
big
the chat.
question.
Yeah, send in the thread. We'll take a look at the
All right.
Java. Okay. All right, let's
Thanks.
thank you. Let's keep going. So once you have a chain of blocks, right? As the first one we talk about is why do we want to have a chain of blocks? The first one you can increase the security for the blocks, right? You can even increase the cost. You are producing the fake blocks because it's much more expensive to fake in a chain of blocks than just a single block, right? So I think I also put one example, simple example here. Once you have a chain of block, for example, you have 2 blocks, right? So now you can compute all kinds of things because in the block header, if you will remember from the last article, that's a field, right, called the timestamp. So basically this is the time, suppose the block is mined. So you can, okay, sorry, that's my son. You just get him out of here.
Guest host.
Okay, yes. Yeah, he is very interested in the blocks. So, okay. So sorry about the intrusion. Let's keep going. So once we have the 2, let's say we have 2 blocks, right? So you have timestamp, then you can compute the difference, right? So that's the example I put here. We know the block time on average 10 minutes, right? For here, I just have a very simple betting contract. Alice and Bob, they are betting whether the next block is going to be mined within 10 minutes or over 10 minutes, right? So the way they do it, they put this, again, they have this contract, they have this transaction containing this contract, they broadcast it, and then the next block will be mined containing this transaction. After that, they can compute the time difference. If it's less than 10, Alice wins. If otherwise, Bob wins, right? So very easy case in this contract. Again, I also mentioned instead of pushing 2 blocks, if you want to have more confidence, right? You can push, let's say 7 blocks, right? So you have 6 blocks piled on top of the first block. So you have more confidence because it's more expensive to fake 7 blocks than just 1 block. Any question for this article here?
One thing I would point out is just that you at the time the contract is broadcast, you know a previous header that already is in the chain, right? So like you could include the previous header from before the contract was broadcast in the contract itself, and then require not only that a single run of blocks is made, but that it links back to the header that we already know is valid according to a block that was before the contract exists. And so you could go back to you could anchor it back, and then you could go forward to a number of blocks to get some confidence. And then you could code up. I'm not sure if you have implemented this, like with I don't know what the current Amari DAA is, but like you could have the moving average to make sure that any blocks that come in are following, you know, whatever moving average and, you know, in consensus based on the difficulty at least. And you're not going to be able to validate the entire block because you're not running a full node inside of script, but you are able to check the sort of the header for consistency. And so I think that can provide a significant increase in the confidence that you have. And then you could even extend it further by having, here, let me pull up something I wrote down. You could extend it further. Screen? Oh, well, I just have my, I just have a little notepad that I opened up to write some things. But there would be so if somebody does provide a fake header, if they do push a header that is like fraudulent or designed maliciously to take money out of this contract that it shouldn't, even if they did all the proof of work, even if the script passes, now there's evidence that they did provide a header which was not in fact in the blockchain, which didn't end up being, you know, accepted by miners, and so there's immutable evidence of fraud. So I think that's also really cool. So cool. Yeah, I mean, nice. I mean, lots of kind of checks here that. Yes, wonderful. Yeah, so, I think it's just very quick, one sentence. What the BCH guys call the checkpoint. They are very good at checkpointing. So go ahead, and, Samir.
Yeah. So I just wanted to add. So one more thing is like on the when we're creating in the SPV network, when you're creating a transaction and sending it over to a merchant, you also keep a copy of that transaction. So whenever you or the merchant broadcasts it, then miners create a block header, but you also retain the transaction. So in the future, when you download the block header, you can also do a check against the block header whether your transaction is exist in the block, is part of the blocks or not. So that way you can, because you are 100% sure that your transaction is valid, then now your transaction becomes a checkpoint for the block header as well. So there has to be a mechanism where the SPV or whatever network is able to keep a copy of your own transaction. So there will be a bridge between your transaction to the block header via the Merkle proof, but we can do a check both ways. You can do a check from the public network to your private network, and vice versa. So that way we can get a foolproof validations as well. So does that make sense?
Yeah, totally. Yeah, I think that's a huge difference between what we do here and BTC or other blockchains. Right? We are kind of treating this almost like a cash, right? A transaction is almost like a bill, right? Dollar bills you can pass around instead of just throwing it into the ocean, and the whoever the receiver is has to find that the bill in the ocean or on the street, whatever. Peer to peer, yeah.
Yep.
Okay, cool. Any other comments about the chain blocks? Yeah, the Txs one is very good. I think it's you can, for example, right? He just said if you want to just to see next few blocks, you can even actually hard code the current block, the latest block. Then you can make sure all this new blocks they have to point back, right, to a checkpoint. This just adds more confidence. I mean, you can still fake it, but it's even harder, right? Because now And
we do checkpoints. We do checkpoints, but it's on a per UTXO basis, not on the whole blockchain like BCH. So just like trolling them a little bit, like, well, their whole blockchain has one checkpoint for the entire chain, where we can allow anybody to make any checkpoint at any point for their one single UTXO, and then it can be independent of everything else. And so better system, I think, for that reason.
Yeah, we'll leave you to whether the BCH boys agree. But yeah, we can check a point based on block, or as you said, right, on like a transaction or UTXO. Yes, not only just blocks. Okay, cool. Yeah, that's the kind of feedback we want to hear, because once you have this building blocks primitive, you can build all kinds of other things to further either increase the security, or you can have new ways to use this information, right? You have blocks, headers, you have transactions, and then you have a chain of blocks. Then you can devise all kinds of new ways to build all kinds of new contracts in it. So if no further question, I'll go to the next. So we just talked about part 2 is you get a chain of blocks, and the part 3 is, so sometimes you want to know more specific, more further information that's not explicit in the block header, right? For example, a lot of time you want to know the height of the block, right? Block height, right? Because for example, maybe somebody lock up some coin, right? And you're using unlock time, right? Unlock time, as we know it, is the earliest time that a transaction can be mined in the block. So it has usually have 2 representations, right? One, you can use the absolute time, the Unix time, right? Or you can use the block height. So in this case, you can also, you want to know in the smart contract, what is the, if you import some block header, what is the height for this block, right? So, but it's not, if you just look at the block header, the information is not there. And that's why this trick, like we can use this trick to indirectly get this information. I think this trick is very nice. I like that. So if you look at the transactions, so here I'm again showing one block. At the beginning is the block header, and immediately next to it is the first transaction, usually called the Coinbase transaction, right? This is the transaction that miners get paid. They have all the block rewards plus all the transaction fees. So this is the Coinbase transaction. So this is the transaction we are leveraged to get this height information. So here, this is there's a BIP for Bitcoin improvement proposal, actually 34. So this is basically the consensus rule that's added by none other than the Bitcoin core developers. So you can argue whether it's good or not bad, but the reality is here, and it's consensus rule, meaning all the miners have to follow this rule, even on BSV. So if you look at the Coinbase transaction, so for Coinbase, it's just like any other regular transaction, Bitcoin transaction. You have inputs, you have outputs, you have all kinds of field, right? But here's the difference, because it's minting new coin, right? So it's not spending from existing coin. So basically, the input you can think you can put anything because it doesn't matter, right? So usually you put the private. This is the out point, right? So basically, this points to which UTX transaction you are spending from and which of the output you are spending from. So you can actually put the now values. Usually, I think now is standardized to be if the previous hash has to be all 0 and index has to be all F. So that's not the part we care about here. We actually care about the so-called unlocking script in this input. It's also now, right? It's invalid. Doesn't make it can be anything, right? It's just fake. It's not spending from any locking script, so it can be anything. And this standard, this BIP basically says the block height has to be the first number here. So if you read this first number, that this Coinbase must be in a transaction with the height of this number in the block. Actually, the miners will enforce this. So if that's a way we can get to know the Coinbase transaction, then we can extract the height information from here, right? Follow me so far? So 2 steps. First, get the Coinbase. Second, read this height information from the Coinbase. So how do we get the Coinbase transaction? There are a number of ways, right? I'm showing 2 ways here. One is, as I said, right, you use the fact the specific field is actually now is invalid. So if you push a transaction, as we said in the part 1, right? You can, once you have a block header, you can know any transaction. You can push just this Coinbase transaction in. How do you know it's Coinbase? You check a few field, right? Because no other if there's no other transaction that has this, you can put this field in, right? Because if you put this in, you'll be rejected. It will not be in the block, right? Because you are not spending from anything. So if you check this few field, you make sure, for example, this is all 0 and the next field is all F. You know this is the Coinbase, right? So this is just one way. And So you push a transaction, you push it, the Merkle proof of it, you check it's in this block, and in addition, you also check it's a Coinbase transaction. You verify it by looking at this specific field. Make sure it's good. So that's number one way. We also have another way, right? Because if you look at the Merkle root here, right? I'm drawing one example here. If you look at the Coinbase transaction, because it's the first one, right? So it's always on the leftmost of the tree. Make sense? So what does that mean? If you are on the leftmost leaf, all the Merkle path of this transaction will always be on the right branch. You see here, right? For example, this is Coinbase. We have 8 nodes. Then this is the circle in red. This is the Merkle path, right? You can find all of them are on the right. So that's another way to check it, because Merkle path contains which branch is in, right? You make sure all the nodes on the path must be on the right branch. So if they're all on the right, you are very sure. You're sure this transaction is the first transaction, aka the Coinbase transaction, right? So after this, you can have the transaction that's a Coinbase transaction. So you can just extract it. This is the line here. Basically, this function, you can, once you have Coinbase transaction, then it's very easy to read the field here to extract, right? To extract the height of the block. Make sense? Okay. So
how do you know how long it's going to be though?
Oh,
For
if you,
example, if it's what if it's like 100 years from now, and now there's one extra digit.
Okay, so good question. So if you, let's zoom in, right? Basically, if you look at this first number, it's 3. This is basically the length is encoded. It's a variable length, so it doesn't matter. Even 100, 1,000, like 10,000, okay. Yes, it's still there. This number will tell you how long the length is going to be. So if it's 3, the next 3 bytes encodes it, right? So if it's, I don't know, like in 100 years, maybe, I don't know, you can do the math, right? On average, 10 minutes every block, you can do the math, and probably maybe, I don't know, 10 bytes, probably not 10, 4 bytes or 5. You can know this, it's encoded. Yeah, good question.
Okay, cool, that makes sense.
So once we have the height information, right, this is another additional information. You can get trust listening, then you can do all kinds of things, right? I just showed one example here. You can do a check log time. If you know about the BTC or BCH, they have this opcode, right? You can do op CLTV, right? And we get rid of it. So actually it's another way, right? We showed one way to use the op push transaction. You can enforce this, but here's another way, right? You can use, because you have height information. Once you have height, you can require it to be no less than, let's say, 700,000, right? So this is essentially check log time. You don't need the extra time. But also you can do, if you can know the height, you can do a lot of things, right? You can say, oh, what if I have a contract, let's say with Tau, right? In the next 10 blocks, you have to mine at least, you have to include this transaction into the block. Well, how do you do it? One way is to the height of all this, right? For example, from 720,000 to 720,010. So you can you push your contract out there, right? It says only if the Tau mines this, you can take the money, right? This is trustless. You don't have to trust on Tau or whatever. Either Tau mines this, containing this transaction, or it doesn't mine, and there's no way you can unlock the transaction. Right? So here, I forget one thing here. So once you have Coinbase transaction, right? One information you can get is a block height, but there are extra information there, especially for BSV, right? Because you can probably also get a miner ID if they are following the miner ID. You can probably get many other extra information from there too. So you can say, oh, only if the next 10 blocks is mined, one of them is mined by, I don't know, SV pool or Gorilla pool. You can do all kinds of fun things. Yeah. Any other comments?
It seems like a check lock time, but better because it's check lock time, except for you can do it within one block. So not only must be greater than, or yeah, must be greater than, but also could be less than. So
Yeah,
you must
less
use
than,
this.
yeah.
You must have this within the next certain amount of blocks.
Mhm.
One other thing you can do is you can take the amount of the Coinbase transaction and figure out how much fees the miner has made from this particular block. And then once you have the amount of coins, you can create an insurance contract that sort of stabilizes and subsidizes or provides less risk for the miners about how much they'll make in any fees from their block. And so it allows kind of the same, like how you can
attack other coins.
Yes, you could do that. I wasn't recommend that one.
Yeah. Let's not say it aloud though.
Right.
Don't give Greg Maxwell ideas. Yeah. They can attack.
Well, I think he would have to use BSV to execute any of these ideas, but right. But you can make a contract that pays to the miners, and essentially the same way how we can use finance and the tools of finance to make it so that the farmers who are growing any corn or anything like that have the risk transferred over to somebody else. The miners who are actually, searching these blocks and ordering the transactions can have the risk about, how many fees they're going to earn in any particular block transferred using an insurance contract, using just the amount. So I thought that was kind of a cool thing I thought of that you can do with the Coinbase.
Yeah, it's like, for example, you just let's say you are like a very small miner. You want to mine solo, right? But as we know, right, if you're solo and you don't have many mining machines, on average, let's say you have only one like a S9, whatever, you can on average you mine a block every 4,000 years, right? Or something like that. So, but somebody want to decentralize, right? They want to, let's say, if you're like, even if you're solo, if you mine, I don't know, after you got the block, you only get let's say 6.3 or 7 BSVs. They can say, you can, if you mine one, if it's less than 8, I will give you the difference, right? Almost like subsidy, yeah. Just fun experiment, yeah. And then, as you said, you can always play with the finance side of it. It's like, the miners kind of like farmers, right? They kind of like, it depends on the, on the average, they know they're going to a certain amount of coins, but it's dynamic, right? It has variation. So maybe they have some kind of contract, smart contract, then can hedge against such contract, right? For example, in the next 1,000 blocks, I should mine at least one, right? But if I'm not, if I should mine like collect 10 Bitcoins, but if I get less, then I'm going to, it's like insurance, as you said, yeah.
If you got less, and if you got more, then you pay it to them,
Oh, okay.
So if you got 11,
yeah.
So that you have some locked up already, and then that way, if you make more money, then the insurance gets the money. If you make less money, then the insurance pays you the money. The insurance is on average going to earn a little bit of profit from you because over the long term, it's going to average out. But in the short term, you get less risk because you're always going to have a certain amount coming in.
Nice.
So it can be locked up like that. So just you can use the amounts and do some fun things like that.
Yeah, so I also want to emphasize, so lock time, you can only say after certain blocks, right? But here using this trick, you can also say it's a range, right? You can even have more fun, right? So from 1,000 to
only
2,000.
On Sundays.
Only on Sunday, or only during the meetup, right? If you mine a block, right? During this meetup, we will tip you, right? If you earn less fees, right? So you can do all kinds of things, yeah. Yeah, that's a good idea, actually. If you have to do some kind of like a live card, so you want to make sure people want to join. So if the miner, I don't know how to, they can even have a certain service for this. Yeah, only Sundays, or whatever. Or only after court case, something. I don't know. If the cracks coin move, you can then check the move, right? Because you can know let's say block 9, then you can check if it moves. You have that SPV proof.
You can have a
put
betting
in,
market.
You can betting, and nobody can shut it down. Almost, it's very hard to shut it down, right? So,
You need a court order to revoke the transaction, but there could be a speculative betting market for how likely it is that the block 9 coins, for example, would move, and that could be provable in script.
Yes, yeah. I'm not, no legal advice here, but we are just talking about if it's technically possible. Okay, that's a disclaimer.
Right. Yes, it's not. You got to be licensed to do some of those things.
Another fun example you guys have? You can think of? Yeah, another one.
No.
Yeah, as I said, it's not recommended, but technically it's possible, right? For example, somebody wants to attack some other chains, they can put a boundary, right? Say, let's say this chain now had top tip is at let's say 1,000, right? And now I want to pay a contract. If you mine blocks, that's reverse, almost reorient back 10 blocks, right? Starting from 990, right? If you mine on top of this block, I will give you 1 million Bitcoins, right? So it's just something fun, yeah.
Because you can put Litecoin block headers in here. You can put Dogecoin block headers. You can put any other blockchain's headers in here. And this is where you can start to run things inside of BSV and there's some other interesting things like I haven't even thought about yet that probably I will think about in the coming days and do some interesting things with. But
now you
can do a lot.
You can even it's not only specific to the blockchain like a Bitcoin family, right? But you can even push the Ethereum, right? Because then you sliding, they have a different block header format, but it's the same thing, right? You can probably import them and bet on them. Yeah, you can do cross chains, right? We're all family, so good.
Well, subsidizing, yeah, you can make a bounty that says, well, if you mine this Ethereum block that has this transaction versus the other one, then you get BSV. And I wonder if you can even like run, well, this gets a bit more complicated, but I wonder if you can actually evaluate the scripts that are inside of, for example, Bitcoin transactions on BTC inside of the script interpreter so that transaction A can spend, we can check if it actually spends correctly the outputs from a specific one. And then we could almost like have a running copy of BTC on BSV in some sense, not in a complete sense, but there are some interesting things that can now be considered because like this is a new thing and it's interesting to see what people are going to come up with.
The good thing about the BTC is the script is very simple, right? You don't actually you can do a very simple. They only have a so-called standard transactions, so it's very easy to figure out what kind of a transaction. You don't even need a full like featured virtual machine or interpreter for them. They only have like 4 type of transactions, so you don't even need a full feature heavy interpreter. You can know them. I think a BCH is a little bit heavier, but if you look at the boilerplate, there's also one guy already code up like a Bitcoin virtual machine in a Bitcoin virtual machine. I don't know if you've seen this, but I'm going to show it later. Yeah, basically you simulate the 2 stacks, right? So you have 2 stacks, right? You can you can simulate that way. It's like a virtual machine inside a virtual machine. You can do it.
Right, just an if ladder, a switch, and it says, well, if the opcode is this, then run this opcode, and if the opcode is that, then
pretty much. Yeah.
Very simple. I wonder EVM could. I don't know.
EVM, I don't know because they have a different memory architecture, right? They have a stack, they have storage, they have a memory. So I haven't checked. Maybe doable, but probably just expensive. Yeah.
I think you'd end up running the entire Ethereum network in one UTXO.
Okay. Yeah, that's a model, right? That's the global state, right?
Yeah.
Global state. Yeah. Okay. Any other examples? Fun or practical? Okay. Yeah. I mean, we can still think about it, and then while I go to the next one, just finish the
Mhm.
logistics. Okay. So the last part I want to cover here, which is actually my favorite part, actually. So let's get into it. So part 4, basically, we want to know. In the part 3, we get to know the height of a block, right? But in a lot of time, we also want to know how many transactions in a block, right? Because, for example, you want to know kind of like approximate the block size, and also sometimes you want to compute even the transaction per second, right? The TPS. We talk about scalability. The number of transactions is very important metric, right? So, but here's the thing: we talk about the Merkle proof. Once you have the transaction, you can put it in the Merkle proof. So let's look at one example here, right? So this is a Merkle tree with 4 transactions. You can know the height, right? How tall is the tree? Is 2, right? You can also know very easily to know how many leaves are. If I give you the height or the depth, how long is the Merkle proof? Actually, the observation here, the length of the Merkle path, right, is equal to the height of the Merkle tree, right? So for example, here, if I'm talking about the rightmost, the last transaction, this is
You're talking about a balanced tree, right?
Yes.
Okay.
Yeah. So if it's a balanced tree, it's so-called, sometimes people call it, technically it's called a perfect tree. Basically, it's always to the 2 to the power of n leaves. So if you know the height is n, you know, right? If it's full, it's 2 to the power of n, right? If it's n, you know at most is 2 to the power of n, right? But what's the lower bound? Tai, do you have a?
Would it be 2 to the n minus 1 plus 1?
Oh, yeah, that's the number here, right? Because if you are less than this, you don't have a level n, right? You have a level n minus 1. Basically, for level n, for height n, you have a 2 to the power of n. So that's the lower bound, because if you're less than this, you are not going to have height n, right? You are going to have height n minus 1. So this is give you a very good range, right? But if you only have small numbers, n, maybe like a 3, right? You know it's between 5 and 8, right? It's good range, right? But what if you have like a 10, right? Then it give you a very wide range. You can almost have you have a range, but it's not precise. So the question here is, can you get the precise number? Can you get to know exactly how many transactions in this block, just give you the block header? Can you know this? So it seems like impossible, but that actually that's a very good trick that detected by this BSV guy. I think I put in the reference. You can check out his post. Basically, it's a very clever trick. So first, let's look at the full tree, or let's Tai call it. Some people call it a balanced tree, right? If you look at this full tree, technically called a perfect tree. Basically, if you look at this, so in part 2, we get to know, in part 3, we get to know the first transaction, right? Which is Coinbase transaction. What if we can know the last transaction, right? Because if you learn the last transaction, you can almost sure you can derive how many transactions in this, right? But the key question here, how do you know is the last transaction? So one very tempting way to try is we have shown before, right? If you want to know if it's the first one, you just check if all the Merkle paths, nodes on the Merkle path is on the right branch, right? So that's how you know. Seems doable here, right? If it's a full tree, you see here, right? This is a Merkle path for the last one, it's all on the left. But unfortunately, this doesn't hold if not full. The tree is not perfect. For example, the counter example here, right? So this one, if this tree, I think I'm not drawing two transactions here, but this block has 5 transactions, right? This is the last transaction. This is the Merkle proof, but you can tell, this 2 is not on its left, right? It's not on the left branch. Actually, it's on the right branch. Only this one is on the left branch. So what do we do here? So the trick is based on this sentence I put here. So we know, right? When you hash a tree, if it's full, it's very good, right? You just put two, you concatenate them, then you hash it again, you go up level, you repeat this until you only have one root, right? But what if it's you know, at the last, for example, this one node, right? It doesn't have any node on the right. What does it do? So in the actual node software, so if it's even or if it's odd number, you are on the left and you don't have any node to pair with you on the right, you just duplicate the node. Basically, you hash it by concatenate it with itself. For example, here, right? If this is a leaf node, and you don't have any node out there, what do you do? How do you get this in the middle node? You basically copy it, right? You copy here, you concatenate, you hash it, you get this intermediate nodes. So what does this mean? So that means if on the rightmost node, if you look at its Merkle path, if the node has any node that's on the left branch, on the Merkle path, sorry, on the right branch, what does it mean? Ty?
Oh, you'd be you would if it's got one on the right, then you don't need to duplicate it. But if it does, then you'd hash it, and then you'd go up and just look for the second one. And if there isn't one, then you just keep doing that until you're up at the top.
Mm-hmm. So
and you can
this
know
is
the last.
Yes. By implication. So let's say I'm giving you a Merkle path for the last transaction for sure. I know it's a last transaction, and I find some nodes along this path is on the right branch. For example, here, what can you say about this nodes on the right? What can you say? Is there anything you can say about this?
Know that it's not valid, right? Because you're hashing itself, and if you're hashing something that's not itself, then you know there's something else to the right, and this one's not the last one.
Exactly, bingo. Yes. If there's anything on the right, it has to be the same, right? It has to be duplicate. Otherwise, we just said, right? It has more nodes on the right, right? So if but this only applies to the last node. So if the last node, how do you verify it? You get its Merkle path. If somebody node on the left, you know, right? It must be different from you, right? What's at the current level? If it's any node on the right, this right sibling must be equal to the current node. Does that make sense? I think this will take a little bit of time to digest, but this is the trick basically. But this only applies to the rightmost, right? You can draw a few counterexamples to try to convince yourself. I'm not saying this is you can know immediately, but the trick here is by checking the Merkle path, if it's on the right, it must be it must be the same with the current node. So, and if it's on the left, it must be different. So if you do the check for all the nodes on this path, you can be sure this is indeed the last transaction. Okay, but the details you can go ahead.
I think there was some code written around the days of the TSC Merkle proof standard. There was some JavaScript code I remember running across where, using their Merkle proof format, it would show you basically the same. It would do those same checks and check if it was equal. I don't know. I think it's on the. It might be under Bitcoin SV specs, that repo or something like that. But
yeah, can you share later? Can you share later?
Yes.
Not now? Okay, yes. Great, thanks. Okay. Once we have this proof, right? Now we get the last transaction, and from last transaction, then it's actually very easy to know how many transactions in the block. So if you look at this graph, right? So for anybody who has been into the binary tree, you can easily know this is how you encode it, right? For example, this is a binary index for all the blocks from 0 to 8, right? 0 to 7, sorry. You have 8 starting from 0. So this is how, if you go to the right, it's 1, right? Go to the left, is 0. So that's how you encode from the top of the tree. So once you know the last one, you can just actually follow its Merkle path. So if it's the node is on the left branch, you go right, right? If it's on the left, you go right. If it's on the right, you go left. So that's how you go to get to the index So once you have the index, right, because it starts from 0, the number is just simply you +1, right? Once you have the index for the last transaction, you just +1. This gives you the number of transactions. Any questions so far about here? Okay, that's good. Okay, so once we know the number of transactions, again, it's almost like the previous examples. We can have block height, you can have blocks, you have transaction. Now we can have the number of transactions. You can also do a lot of fun things, I think, here, or practical things. I just give 2 examples here, right? The one is, if when before any kind of stress test, people usually say, oh, can you donate some coins so we can fund this stress test, right? But what if there's a way you can make sure, for example, I only donate to this, you can only unlock this coins, lock in this contract if certain block, let's say the block height with 800,000 contains more than 1 million transactions, right? This is just one way, right? Just have fun. You want to make sure the stress test is successful, right? Only then you pay out, right? So this is almost like a crowdfunding for stress test. But also, as I mentioned at the very beginning of this article, once you have the number of transactions, you can also extract the timing information from block header, right? You can either do the block height or you can do the timestamp. So you have time, you have number of transactions, you can divide this two and you get the TPS, right? So then you can even play with a lot of fun example. You can say, oh, I sponsor this stress test, but only if the TPS reach, like, let's say, the last Terranode demo, we have 50K, right? I mean, they have a backstage at 100K, but we can say, oh, if you reach 1 million TPS, I'm going to lock up 1 million Bitcoins for you to take, right? This is just another, you have TPS, and this, the good thing about this TPS is you have very high confidence. This is real. This is not something you reported. You can actually get it from on-chain data. You are not relying on any third party. So this is just one of the few examples I can come up with. What do you guys think?
Yeah, I was thinking, and luckily we'll never need to use this on BSV because we're not expecting it to ever get congested. But if you know how many transactions per second there are, you can tell if it's at capacity or not. And then you could prioritize a contract based upon, if there's so much traffic on the network, you could say, oh, we're going to wait and do this later. Does that make sense? So you could have your contracts kind of like operate based upon if the network's at capacity or not. It's one of the use cases I thought of. But again, we'll never have to use that on BSV, hopefully, because we'll never be at capacity.
Yeah, we just talked about in the last article, right? We can use this to any other blockchains because they always have congestion, right? You can say, okay, if this TPS on chain is very high, you can say, oh, because if you do it now, right, you are going to pay more fees. I'm going to pay you back, right? If it's low, then it's almost like an insurance. You kind of like a pay constant fee, right? You are like almost like buying fee insurance, right? So if the TPS is high, you can even know the threshold, right? You can even do because you know the capacity. Maybe, for example, on BTC, if TPS is it now reaches 80% capacity, which is 4 transactions per second, right? So you can say, oh, this now is kind of congested. So if you can prove this is congested on BTC, I'm going to pay you back, right? So vice versa. If it's low, okay. Yeah, hopefully we don't need this on BSV, as you said, because it never get congested.
Yeah, I mean, if you look at, there's always some things like Amazon, even though we think of Amazon as having like the best infrastructure and whatever, there's always these moments of shock, whether it's during holiday season or whatever, where they do actually get congested.
Next week.
So
Black
maybe
Friday.
you could.
So
yeah, exactly.
Black Friday.
So maybe
deals.
there could
insurance.
Yeah, maybe there can be a even though it's very, very rare and hopefully it never happened, maybe you could have some sort of use case for this where you can do something based upon if there was a shock to the system and there was too much capacity or there wasn't enough capacity on BSV.
Maybe even pay out, like have a big, huge actor in the space that has an interest in this, unlock a tranche of funds that goes to miners so they can buy more hardware based on the amount of hash, based on the number of blocks
there
they've
you
got
go.
out of the past 100.
Mhm.
So like if I'm a big giant
Fix-
holding company or hedge fund or something, and it's really in my interest that everything keeps running, and I have this contract that's out there and it basically says, well, if the TPS ever goes above a certain amount, then we're going to look at the past 1,000 blocks and then just distribute some funds to the people that made those last 1,000 blocks, to those Coinbase scripts, to the same ones. And that way they have a bit more money, and that way they know, like, because this contract exists, that yeah, if we ever do reach this, then there's a contingency in effect that now we can unlock some funds or something. I could picture like governments or large, very large, like, financial actors being able to do something like that.
Yeah,
Yeah,
you can
then
even be
the secondary condition is we have to make sure it goes directly to mining hardware somehow, instead of, because then there might be an incentive to make sure it's always congested to get the funds unlocked.
Right. Yeah. I mean, like that, then you
Oh,
get
you
the
can
politics
even-
of
you can
the
even
constant
encode,
state of
right?
emergency.
you can
Yeah.
you can take it. One is TPS is high, not is congested, right? But you also have to meet another requirement. Maybe say 100 blocks later, now it's not congested, right? You have two conditions to be certified at the same time. So you have make sure they're actually buying the extra capacity to deal
Right,
with this search
that's
demand. You can say,
interesting.
yeah. So you can have a first make sure when it's triggered, it's high, but once you get it, this payout, you also, in order for it to unlock, you also have to make sure sometime blocks later, let's say 1,000 blocks later, you got the TPS, that congested gets dropped down. Yeah.
You could even
And
look
also-
at
Makes sense, yeah.
which miner was the one that actually brought the TPS down. Was it one miner that cleared out the mempool? So maybe they get a reward for that.
Yeah, even for
which,
Coinbase,
which
right?
of the miners that were doing it?
Yeah, you
Right.
can get the miner ID
You can
from
check.
the Coinbase.
Yeah.
From the Coinbase, yeah. If the people always use the miner ID, yes.
Or just use the output script that they used in their Coinbase. Like the locking script.
Yeah, pay
from
to the
block
same address.
reward.
Yes.
Right.
Is there a way to detect the attack that we had with the longer chain from that, a few months ago, they attacked the BSV? That's, you could look at the length of the chain somehow with this to help detect those attacks better.
Yeah, you
Perhaps,
could push
'cause
all the
it's-
headers. You could do that. If you have,
Because
If you can find two like a parallel chains, right? You can do some kind of logic. You see what I mean? So for example, the attacker chain eventually is going to be shorter, right? Because the honest miners will just keep will never follow this dishonest miners. Doesn't matter. Maybe temporarily that chain is longer, but eventually it gets much longer, right? For example, I can have a contract, let's say I pay out. If you have two parallel chains, and one is like 1,000 long, 1,000 blocks, the other is like a 900, right? You can almost like subsidize. No, you are like a founding honest miners, because the only case that can happen is it's like you are defending the chain, right? You have 1,000 versus 900, and they are disjoint, and also they have the same starting point, right? The split, the fork, right? You can check from fork point. One is like a 90 blocks, the other is 100, and then you pay out the minus on the 100 blocks. Does that make sense?
Something using.
Okay.
that should be top priority to go and try to work that out.
Okay, if somebody finds that, we can even have some condition, right? Everybody donates to this, anyone can pay, right? Lock into this coin, lock to this fund, but only can unlock if this ever shows up. So it's almost like grassroots, protecting the longest honest chain.
But on the other hand, you could also fund attacks with this. right?
Attacks,
So-
yes.
Yes, you
Yes.
could.
You can do
Yeah.
vice versa. Yes.
But it's clear what
Isn't
they're.
there a problem with the BSP that's got embarrassingly low hash rate, right? I mean,
Mhm.
I saw that, the BTC's got octobytes. It starts with E, right? Octobytes.
Yeah, X.
Then
We're like a
BCH got
petabyte.
petabyte,
Petabytes.
and then BSB's got like, gigabytes.
Terabytes.
I mean, it was
Not
tiny,
mega.
right?
I
I mean,
thought it was
it's like,
Gigamax.
I mean, a giga, whatever,
Gigamax.
hashes.
Giga
I mean, that
hash.
was, but it wasn't terrible, tetra maybe, but it's embarrassing. I mean,
I
the
know.
chain's almost useless. I mean, they have to protect it with these quirky, right now, they're just protecting it with some, miners are cooperating, right, to sniff this out, sniff out future. It's not very good, right? Like they never thought, I mean, Craig Wright never thought that there'd be
Multiple
another
chains.
2 chains,
Yeah, I
copies of his chain. He thought his chain would be the only chain. So its
Mhm.
hash rate is the hash rate. Is
Mhm.
now he's not the only chain. He's got copies that are stronger than his running. So like
For now,
it's no good.
yes.
Mm.
Yeah, we have to ask him
Well-
whether he foresees this multi-chain, parallel chain, Bitcoin, all SHA-256, 3 chains. Oh, now four chains. Yeah, and you got
With stronger hashes, and he's at the bottom. I mean, his one's at the bottom. So I don't know how we ever convince businesses that you can do business on BSV when they look at their other ones that just buy hash power and attack it. Unless we put
What are
something
the-
like this, what we're saying, we have to add it at the sCrypt into it to
Yeah,
better
we're
sniff
just
it out, the whole chain.
Mhm.
One of the things I just thought of with this, using that same mechanism you just described for parallel chains, miners could insure themselves against orphan risk. I mean, you could buy orphan risk insurance. So if you mine a block and it's valid and it is orphaned, then it's the correct difficulty, all the transactions are valid, whatever. You push those 2 things into the you provide the headers for the correct chain, 12 blocks later or whenever after the correct chain is like decided on, and then you have your one block that was mined but it was an orphan, like how Ethereum does with the what is it, like uncle blocks or
Uncle.
something.
Yeah.
But the miners, if there's a market for this, I'm not saying there's a market for it, but I'm saying from a technical perspective, miners could buy insurance to what is it, they pay in and the other people pay in, and then there's a pool that's managed by this contract, or one UTXO managed by this contract, and then if there is an orphan, then maybe they get a payout or something from the insurance provider. But then again, that insurance provider has a very strong incentive to make sure this miner doesn't have orphans. So maybe that is actually not an insurance provider, but rather a fiber optic company that connects miners together or something like that. I don't know. But maybe there's a market there that could reduce the risk to miners for mining these big blocks on BSV and bring more hash rate over. I'm not sure.
Well, does anyone know, was money actually lost? Because I thought there was a tweet saying at that time a few months ago, oh, I lost 18,000 Bitcoins during to that
That's
attack.
far. I think usually you can, the only possible way is you do some kind of if you buy a car and then you use zero confirmation, right? And then I could see that case, it can happen, but I strongly doubt it.
Because they recommended waiting for 6 days or something like that. I think during the attack period, they said you got to wait a long time. Please wait a long time. It's ridiculous. And who wants to wait that long? So
usually you don't have, but they just because they don't understand the Bitcoin, how Bitcoin works. Because it's like a zero conf, right? It's for a low value item. You can just buy it. Yeah, but even for high value, you don't need 6 days, or maybe all this exchange you have to wait almost 24 hours. You have to wait for I don't know, 200 blocks or something. Yeah. It's just they don't understand it. You don't need that. For example, here, right? I think a low hash, it's not a good thing, but also it's not end of the world, right? As we showed, right? So if all the honest miners, doesn't matter the attacker just temporarily have a longer alternative chain, But if the honest miner know these guys are attackers, they just don't consider, they just never buy it on top of this change, right? Eventually this change, doesn't matter how long, they're going to die out, right? Unless they will actually want to fork BSV forever, right? Then they can do it. But otherwise, eventually they're going to be wear out, right? That's what happens in the last few reorg attacks. I agree, the hash rate is better, always better to have more hash rate, but I'm saying is even it's a low hash rate as we've seen, right? We can still defend it. But I mean, yeah, it's a hassle because then you just, some people can just burn like a few thousand or even tens of thousands they can attack. If we have a BTC level hash rate, they may have to burn like 1 million just to attack it. Just make it harder to defend. But it's annoying, yes.
Yeah.
It's annoying, yeah.
Yeah, very annoying. I mean, it
Yeah.
was out of action
The
for,
only
you
way
know,
to
for
get,
weeks.
like actually the hash rate up is to actually use the chain, because the more transactions, the more funding the miners get,
Mhm.
and they will compete, right? They can put more resources into hash.
Yeah, transactions, yeah, transactions.
Hmm.
Or they have a contract like what we propose here, right? It's almost like crowdfunding.
Fee to block
Defend.
reward. The fee to block reward ratio can be betted on. You can make a contract that says that, you know, we want the fee to block reward ratio to be a certain amount, and that ratio is really what's going to drive hash rate to BSV, because you have basically independent of the price, you're earning, you know, for example, if there were, I don't know, 20 BSV in fees per block and 6 BSV from the block reward, the subsidy, I mean, you'd have 26 BSV every block you mine. And so the profitability of doing that versus mining on other chains would cause miners to move over if they want to maximize their profit. And so the way to cause that to happen is to create transactions and enable use. And so, I mean, a lot of the projects that I'm working on, but I think lots of others as well, are geared towards the creation of all of those transactions. It's a chicken and egg problem, but it's also a bootstrap problem. And I think the bootstrapping is happening as a lot of these infrastructure projects get built out.
I don't know if there should be a standard transaction with all this plumbing added into it to help defend and going forward, that we all have this base class, almost like a base class in every transaction on BSV that contains all this defense mechanism. Like a text to look at the block height.
I don't think it would be on a per transaction level. I mean, these are all really minor level, like contracts that can be set up with miners. Like the transactions are independent of any of these defense mechanisms. They exist inside the blockchain and the miners mine them, but it's about mitigating the risks and modifying the incentives that are applied to miners in such a way that the miners would be able to, you know, basically they might want to engage in these types of contracts with various insurance providers, et cetera, that might be able to offload some of the risk. But that doesn't really have, I mean, thankfully we wouldn't need to change the protocol or add any other change. We wouldn't need to make any changes to transactions that everyday people submit to miners. I mean, the user experience of Bitcoin is I submit a transaction to miners, and the miners mine it into a block. And even during the reorg attacks, I mean, that happened. Like, none of the dishonest blocks got into the blockchain, and I submitted a transaction to Tal, and Tal mined it into a block, and then that block got put into the blockchain. And so, I mean, Bitcoin, you know, continued to work. It was just that a lot of these people running, you know, service providers that maybe don't really understand Bitcoin the best got pretty scared. So maybe they turned things off on some systems. But I mean, Bitcoin is a system. All of my infrastructure continued to work, and I mean, Bridgeport, which, you know, by the way, I think is a solution to some of the chain scanning stuff you were talking about. But I mean, that's a topic for another thing. But
how come they
all that
asked
stuff-
us to do the invalidate block? command, which I tried to run myself. They sent out the request from Nchain, please
To
run
the
and validate
miners,
block,
right?
blah, blah, blah.
To the miners, right? And some infrastructure providers, but not to end users. Like end users were fine. End users still got their transactions confirmed. But I mean, yeah, it would be nice if that wasn't happening. It would be nice if people would not, you know, if they would refrain from making those sorts of attacks.
In the new Node software update contains some like blacklist functionality. Does anybody know about that? I think it created some fuss on Twitter about it. I think now nodes can blacklist other miners, but I'm not sure of the implications that would do to mining.
I know that for a long time, nodes have had the ability to ban certain IP addresses and blacklist, or sorry, disconnect. If I was talking to some IP and then I ran, I don't know, RPC commands, I don't know the specific RPC command, but when I was running a node, I just remember seeing like, I think it was ban list or something like that, .dat, just a different nodes that were misbehaving were kept in this list. And I think that they recently added a policy blacklist for UTXOs. And so that policy blacklist was so that, you know, your node would not mine certain UTXOs that were spent, you know, for perhaps they were frozen by a court order or something.
Freezing order. Yeah.
So it's for transactions, not for actual blocks.
I think it's been there for specific miners and other nodes for a while, but I think this relates to the freezing of UTXOs on a policy level. And I think there's also an option for freezing them on a consensus level, which means that you will actually reject any blocks that try to spend the UTXOs which you've frozen. But I don't know if that's documented or implemented yet, like in a way that I don't know if it's, they've talked about it and they've certainly implied that that's like a thing that could be there because they were very explicit. This is a policy freeze, but they left a very strong implication that there might also exist such a thing as a consensus freeze as well, which basically means you better be in close contact with the other miners on BSV, because if you're putting a consensus freeze, well, gosh, they better know about it. And you better know about theirs too. So different functionality, I think, but with the result with the same goal, which is to prevent bad people from doing these malicious attacks.
4D chess or 5D, man. Same.
Yeah.
Or maybe there's somebody is already betting on whether they already have they read this all this article. They already put a contract to bet on the block 9 Coinbase where transaction will be moved or not. Depending on that, they already place a bet with some off-chain transactions, right? Holding this contract. So that's also a possibility, but only can be unlocked after block 800,000, something like that, or before between some range. That's all doable.
Also,
right? You can code
also
it today.
only if 800,000, if 800,000 is mined on a Sunday.
Sunday, yes, or by a certain miner. It's all You can do all this complicated stuff if you really want to bet it. Yeah.
Wait, where did you see this bet, or is this theoretical?
Oh, theoretically, we're just
thing,
saying, we're just saying with the technique we just introduced this week, you can build a contract, write a contract to build it if you really want. So
only if it snows in July on a Sunday when block 800,000 is mined by Tal with at least 300 TPS, but not more than 441 TPS, will a certain contract be executed.
If it snows.
Right.
That you need.
You could look at a weather oracle that publishes regularly.
Truth, yes.
Of truth, yeah. If this following statement is
if a certain oracle publishes a certain transaction in a certain block about the weather on a certain date, right? Because you can have oracles that regularly publish a chain, and as long as your oracle publishes on-chain data, you no longer have. Remember, we talked about this, and now it's solved. We talked about this problem where it was like, well, the oracle has to engage directly with the the creator of a transaction, but,
Yes.
but no
Yes.
longer because the Oracle can just push they can just put their transaction on chain that says like, I hereby certify that the weather on this day in this location was it was snowing in July. But then now it's on chain and we can just prove the inclusion using a Merkle proof to back to the header chain and then
Makes sense.
validate
I think,
that.
okay. I will think about it, but maybe it's doable. You're just saying that UCDSA based Oracle, right? Because one caveat.
Well, the transaction's already been checked, right?
Okay. Yeah. So you
It's
don't
already
have
been
to.
checked before it's in the
You don't have
blockchain.
to actively unlock some new UTXO. You can just read the old one.
No, you
Because
just read what the data was on chain. From
So
the
you're not
certain
spending.
hub key.
Yeah, you're not spending.
Right.
Makes
Right.
sense.
Just read only.
Yeah.
All right, I have a question for the group, especially Xiaowei, because I know you like these sort of things. It's a real world problem. And here's how it goes. I'll use an example because it's easier to understand. A Chilean hatchery grows Chilean sea bass, which are not from Chile. So this is kind of a tongue in cheek a little bit, but they're growing Chilean sea bass from a hatchery in Santiago de Chile. And they make a digital twin of the sea bass, each one, because they're ginormous. And data A is when the egg hatches a sea bass. And then it gets to a processing plant where it turns the fish into meat. Then it goes on to planes, trains, and automobiles. And there's a big line of people that all
Supply
have to handle this supply chain. Yeah. And they each do their private signature and they add data, whatever. Now, at the very end is a restaurant in, say, New York City. And the patron of the restaurant opens up the menu and it says, fish number one is Chilean sea bass was hatched, I don't know, 4 months ago. And that's $5 a pound. And then for $25 a pound is the fish that were hatched 1 month ago. So the idea being it's fresher, most likely. But the hatchery doesn't want their information to get out too much. And so they're trying to compartmentalize who has the information. So they don't want B, C, D, all the way through Y, different partners to know the date that they sent, the data that they put in the digital twin UTXO. They don't want that to be revealed to any of the middlemen, but they do want the restaurant in New York City to know. That helps them price the fish. So how would you do that so that the information is compartmentalized between, say, the originator and the final destination, but everybody else in the middle is unable to read the date that the fish was hatched?
That sounds like some kind of a cryptography
CDH.
that has to be involved. Seems to me, just out of the top of my head. What if? Go ahead.
Good. One of the good episodes to watch on this is EDI and supply chain and Bitcoin class with Satoshi. I've watched this one a couple of times because it's stuff that I'm interested in. But what could not everybody has to know everything that's going on. But when in that video example, we have the manufacturer. So in this case, I guess it's whoever's harvesting or planting the seeds or whatever. But they create the serial number for that product, and then and then each person along the way is going to have their own kind of private database that's managing this thing. But then you have this universal serial number where you can track this one product across the thing. So maybe that has some sort of help to do with it. I don't know. What are you gonna say, Xiaowei?
I have a solution for you, and it's in plain sight. Actually, yes, it's called Lightning. Basically, you don't use
Lightning.
you don't use Lightning. You don't know the intermediate hops, right? But you can use the so-called like a internally they use this technique they call the onion routing, right? It's like you don't know who the next hop is going to be because it's all wrapped in different layers, and you can only see, I forget either who give you or who you're going to send to. Oh, you only know who's the next, right? So just something reminds me of the onion routing in Lightning, but the onion routing is it can be used outside of Lightning because it's just another way to do routing, like for private routing. So something seems like the idea, the concept can be somehow plugged in here. You only know your next hop, right? You don't know where it come from, but maybe at the end, you can know of this, or you don't care. As long as you get the fish, you get everything is good at the restaurant level.
I see this as a basic data privacy, just encrypt things problem, because what we have is data that we don't want the world to know, but we do want the parties involved to know, and we also want them to know the signatures are valid and it's been attested for a certain point in time. But what you could do is the hatchery and all of these other intermediaries would have a key associated with this data that's like maybe generated for this particular fish or something when it was first created. And so this key is passed along, and eventually when the restaurant places the order for the fish, now the restaurant gets access to this key, which they can use to decrypt the data that's either on chain or on a off-chain storage solution such as NanoStore that does it. But either way, just then decrypt the data and then check what it is. But the guarantees you get are the signatures are correct on the data, it's been validated, and also the data has not been tampered with. And those are the two tangible benefits I see with supply chain stuff going on chain is we want to make sure there's not been any tampering, and we want to make sure the signatures are correct. And we also want data privacy in this, such as in this case. So for the privacy, I just see a simple just encrypt it and share the key with the relevant parties. I mean, I don't think so the person who creates the first step in the supply chain would start with one key, right? And then maybe they pass it to the second one. Well, now the second one has access to the first step's data. And eventually when it gets to the end, you have access to the every person in the supply chain has access to the data from all of the previous steps and all the next steps, because they basically all know this one key. And maybe that's a problem, right?
Yeah, well, here's the thing that and again, it'll be helpful to go back and watch that EDI and supply chain Bitcoin class with Satoshi. But I watched that a couple times, and the advantage that I gleaned from that with doing it this way is that you create some sort of like look, if I give a package to UPS and if there's no thing, I kind of lose track of what's going on. But if there's a serial number that's associated with this product,
tracking
and
number.
UPS can, yeah, but the tracking number is unique to UPS. So we need to have an even more universal thing, right? Some sort of serial number associated with this product. And then UPS can say, oh, tracking number with this serial number. And then UPS may pass it on to somebody else. And then they pass it on to somebody else. But everybody is using their own kind of private database. They don't have to, UPS doesn't have to write to the blockchain every single tiny thing. I mean, they could, but they don't have to. If they want to keep it private, they don't have to do everything that they're doing with this thing serial number. But as that gets passed, as UPS meets their conditions where they delivered it from here to here at a certain temperature or whatever, and then that gets passed on to whatever, you still have that universal identity. And that's sort of the advantage. And so then to answer Jack's question is that the restaurant now has the serial number, and so they can talk to the farmer and reference that serial number, and then they don't have to talk to all these intermediaries. They can just say, hey, when was this fish grown? And here's the serial number. And so hopefully that makes sense.
Yeah, that'd be probably the simplest way to solve it. I'm kind of interested in, I guess, maybe something similar to what Ty was saying, where you could send the information down the line. You wouldn't necessarily, let me add to the problem to make it actually easier. It wouldn't matter to the hatchery so much if B through Y looked and used the key that's sitting there in the data at the encrypted message, because if there was a mechanism to warn the hatchery that they looked, because if I say to you, here's a secret message, in the medieval times, and I put my wax seal on it, when the person gets the wax seal and they go, well, this wax seal is all dicked up, like somebody obviously intercepted the message, so this is no good. Whereas similarly in the EDI example, all the hatchery would need to know is, okay, as long as nobody looked at it, then I know it's safe and it got to destination Z, and then they opened it. Everything's cool. So that would be kind of part of the requirement. But Ty, you were sort of saying like, just use regular old encryption and stick the encryption key as part of the data and send it down the line. And
you wouldn't send the key, you wouldn't encrypt. I've done this before, and it's a real shame. If you encrypt the encryption key with the encryption key and then lose the encryption key because, well, you have it, you don't have it because you've encrypted it with the encryption key, and now it's lost. And also all the data is lost. So what you have to do is, a question I would pose, is the hatchery at point A talking directly with the restaurant at point B?
Yeah, they can exchange keys. Is that possible?
Because they can just do an ECDH.
Yeah, I mean, this might be a theoretical example because I was kind of looking for a super geeky Bitcoin answer where at the very end, maybe the restaurant sends a transaction to a transaction to unlock the, I don't know what I was thinking, but I'm trying to think so far forward that we're like, everybody's just using Bitcoin for everything. So there is no like back channels or any of that stuff.
So with UTXO, like just the transfer of UTXO. So for example, remember Chawei, we were talking about the bounty program, right? So when a restaurant needs a fish, he says, okay, this is how much I'm willing to pay, and just publishes that problem out there. And it's for the hatchery to figure out, okay, this is how because I have the fish, this is how I can solve the problem. But now it's not the problem of the restaurant to solve about how the supply chain works. It's for the next problem is for the hatchery to distribute that over. So he publishes that with their their UTXO saying, okay, I'm going to receive this much amount of money from the restaurant. How much am I willing to pay for this fish to be distributed? Either they can provide their own service or they can outsource it. So it can't a chain of bounty programs where you just distribute the UTXO based on the problem itself. So wouldn't that really solve the problem? Or is that making sense?
I don't know exactly because I'd probably have to take more time to look at it, but I like the idea of the bounties. That's pretty clever.
Yeah, so that's I mean that's what the mining kind of does that as well. So there's a problem out there. It's basically a bounty. Whoever solves the problem, they receives the reward. So it's like a free competition. Where the things gets done more efficiently. So
yeah, the bounties things are cool. I think if I remember correctly, I'll have to rewatch this, but I think what Jack's original question is that how do you, let's say that you have some data that you want to keep private, and you don't want all the intermediary people, whether it's UPS or whoever's handling this thing. You just want the originator of the product and the end user to know. You don't want all these intermediary. I think that was part of the question. So the bounty thing is cool, but it's kind of it's unrelated to the original question.
I mean,
But I don't even remember the original question at this point. So go ahead,
Well,
Ty.
I guess I misunderstood. What I was thinking was there could be like a bounty of I'm not going to look at your data.
Oh,
I see,
okay.
yeah.
That's what I was thinking. But
So
then
B,
again,
C, D, and F just go, oh, I'm happy to make it. I'm not supposed to look at this anyway, but there'd still be the requirement that if they do look, somehow the originator would need to know, because that's enough.
I think
In other words,
that comes back to a problem in information theory, which is I have some information. How do I, unless we're using quantum something or other, how do I prove that I have not observed the information which I have? And so the way to do that, I think, is just to make sure that they can't look by encrypting things in such a way that it's not like I won't look because I'm being paid not to. There's no way to prove that if I have a certain piece of information, I have not accessed it. Just like if I have a piece of information, if you send me a file and you don't control my, you're not observing me at all times, and you're not observing all of the things about me at all times. If you send me a file, there's no way for me to ever prove to you that I have not made some copy of that file. Just as there's no way for me to prove or disprove that somebody has looked at information which they have access to be able to look at. And so the way that this would be solved is if you have information intended for a single party, such as the end user, you would perform a key exchange, an ECDH key exchange, derive a shared secret between you, and then encrypt your data in such a way that it can only be decrypted by the end user. And then that data gets passed through all of these third parties, just like how my IP packets are being passed through my ISP, and then they're going to Zoom, and they're going to your ISP. And during all of that time, in theory, well, I don't know if it's end-to-end encrypted, but in theory, nobody's looking at it, right? Except for the NSA, because they look at everything. But I digress. The point is, the data is not accessible to the people who are intermediaries, because we can't create an incentive around not observing something to which you have access, just in the same way that, if somebody tells me something and then, they don't know every single thing I'm doing at all times, I can't prove to them that, well, I haven't looked at this, I haven't made some copy of it, because Bitcoin does not solve that. I don't think it's, well, in our current frame of computation, I don't think there is a solution to the information theoretic problem of duplication, where it's like, I prove that I have not duplicated this, unless it's done in some quantum way where when you observe it, you hit it with photons or something, and then now it's changed and all of that wonky stuff. But that's far in the future, and putting that inside of a Bitcoin smart contract would be well, that's going to be my grandchild's problem. So Ty Everett III, if you're watching this, that's what you have to do.
Don't worry about it. Don't worry about it, because I can tell you right now that the Copenhagen interpretation, where nothing is real until you touch it, it's going to fail. So that's for my grandchildren. Hey, Dad, he got that right.
The only way we send this video recording to the future is not by uploading to YouTube. For this special edition, we have to put it on chain, the whole thing. So our grandson can watch it and building some kind of like a photonic sCrypt, whatever, 3.0 something.
I did have a thought. So is there a way, and I think Craig talked about this in NFTs or something, but is there a way where you can record, like, let's say that I want to look at data. Okay, well, I can look at it, but there's going to be a record that I looked at that's going to be stored on chain. So the only way for me to open the data is to publish a transaction that I just looked at it on chain. Because if that's possible, then maybe some of the stuff is possible that you can actually see if somebody has accessed this data. So
I would be of the belief that wouldn't be possible, because you need to, so the publishing of a transaction means letting the world know about a transaction that has already happened. And so by letting the miners know about this transaction. I'm not learning any new information that I didn't have before I let the miners know about this transaction. And so because of that, I don't believe, I could be wrong somehow, but I don't believe that I would be able to learn any new information that would be required, such as a key, in order to access information by publishing a transaction. But I don't know. That's just the way I look at it.
It could go through a trusted intermediary. Then it would, but then we would have to trust the
Right.
the guy that publishes the actual transaction.
Isn't it a feature of publishing this data out to the public and not a bug? Because BTC thinks, I mean, the BTC network is, you know, the difference between the BSV and BTC is the BTC network thinks it's a bug. And are we talking about that this is also a bug in the in BSV network? I thought it was like publishing these transactions for everybody to see is the feature of this network, no? Or is my understanding wrong?
I don't understand. I don't understand your question.
I think he's referring to public versus private blockchains. Why do we have a public blockchain?
Because in your supply chain, you know, going back to the supply chain, the problem that was raised was for all these intermediaries to know how exactly the supply chain is happening, and that we think should not happen. Was that a question originally, Jack, that these intermediaries are not supposed to know how the supply chain is happening?
It's proprietary.
Yeah.
The question is just really general. It doesn't really focus on whether your information is public or within the data. It's a general question of how would you get information from A to Z and avoid giving that information from B to Y in your supply chain.
Mm-hmm.
You could kind of answer it many different ways, as I think have been done already here. But I guess I'm always trying to think of as Bitcoin goes from niche usage where you're just thrilled with microtransactions and you're using it for that, or you're thrilled with the immutable ledger part and you're using it for that. And there's several different kind of reasons why you would overpay to use Bitcoin versus, say, Amazon Web Services. But as time goes on, remember, the bigger Bitcoin gets, the bigger the node gets, the prices go down for the transactions. And so eventually there's probably a parity reached maybe after 5, 8, 10 years where Bitcoin itself is storing data and doing transactions about as cheap as Amazon Web Services is. And that's when the whole thing just gets flipped. And so if that happens, then, how does a Bitcoin world look like in 15 years from now when everybody's using Bitcoin transactions for everything from sending messages, from sending a message to another transaction? That's where I start to lose my shit a little bit, because it's like, well, could you use a transaction to hit another transaction and extract data?
I don't think like that's everything will be stored on chain, like every interaction. So you can still keep private parts that are indexed in a Bitcoin way, packaged in transactions and stuff, but you never have to publish them on the blockchain itself. So
I think one way I can think about is payment channels, right? So it's anchored or like secured or settled, but all the intermediate steps, they probably not going to end up on chain.
Exactly, yes.
I mean, we can only see so far in the future, but I mean, I think a good topic for the next one would be to talk about sort of what David was originally mentioning with regard to like scanning the chain and deriving kind of states from it to create analysis and to create like, tokens and other things with how tokenized works.
Without running a full node,
I've just been working on some, without running a node. And so I've been working on some stuff there. And I think I'm at a point where in a week, I will be able to
Okay.
create a cohesive presentation of what I've been working on for the past little while with Bridgeport. And so I could kind of offer my 2 cents on that, and then we can see what people think of kind of deriving things from the chain, not necessarily validating, using miners, but validating on second level, like what's it called, overlays type things. So maybe there's Bitcoin valid things that aren't valid according to an overlay network, and how do we check that? And because if you do that, you can get into things like oracles and even like wallet, how Roger's running into this issue with the seed phrases, those type of things. There, if you can create the right incentives, you can almost solve those in certain ways. And so I think that could be an interesting thing to cover.
One other thing I just want to cut in there, appreciate that. Just a sec here. Is there a way to, one thing that's bothering me again is that Tau and Mempool seem to be the only 2 big miners. It means like they're taking over the whole thing. I don't like that. Is there a way with this, what we talked about today, you can have the transactions seek out the miners to mine them that they prefer, because you can check the mining.
Yeah,
you can have the contract that only
smart contract, right? You can get the Coinbase. At Coinbase, you can get the miner ID. So you can even say I only pay out to this miner if this is a block, a certain block is mine.
You can do anything but Tau or whatever.
Yeah,
I can
if you
answer
say,
Anybody but Tau.
if you say the miner ID does not equal to Tau, you can do that too. Yeah. Jack?
Yeah.
Well,
and then
we
also,
want
to answer your
go ahead.
first part of your question, David, you asked, you're worried about Tall and Mempool, which I'm not even
Centralization.
sure they're around anymore.
Yeah.
Yeah. The
Yeah.
centralization is solved.
Yes.
The centralization is solved really easily. First of all, BSV is tiny. And so someone like a Google would be Tall's worst nightmare, because they would devote 0.001% of their capital they spend on R&D every year to Bitcoin SV. And on the very first day, Tall would struggle to win any blocks. And then it would be a question of Tall would only win when Tall's blocks would probably be ginormous, because hopefully by the time Google's in with all their money and more honesty, Tall would have relationships like you described in the second part of your question, where they would have, maybe Slictionary and sCrypt as customers, and our transactions wouldn't be able to be processed by a dummy with just nothing but ASICs. In other words, it wouldn't be basic transactions. It would be smart contracts and things that Tall has figured out how to do well.
Monopoly.
Well, it's not a monopoly, because basic transactions, Google would own all of
The
those.
specialization.
Yeah.
No, but
in other words,
specialization, they have a monopoly on all the good stuff, and they can charge high prices for even the normal good stuff they want to use.
Right, but I can compete with them if I think their prices are too high, and get good at that as well. It's just capitalism, right? Just people specialize and they get niche markets, and then there's the general case, and then there's all the different ones in between.
There isn't really a lock-in with miners. Like for Google example,
they have to
you
keep
use their systems, and you're locked up. You would have to put in a lot of capital to actually transfer your system to another provider. But with Bitcoin, it's all the same, so it's cheap to switch.
Monopoly without vendor lock-in, so to speak.
Yeah.
Why is it cheap to switch? They're going to be hosting all these services, even like getting the blocks. They're going to be hosting that now in the future. You have to pay to get the blocks now, because the blocks are too big. They're going to have to go through the.
That's what I think.
API.
That's what I think.
Nothing's
Bridgeport
free,
solves, and I think we can talk about that. I think we can talk about that next time.
One.
But that is one of the things that I think Bridgeport will solve, is this idea that APIs derived from chain are going to be hosted in certain ways, and things like that, and then we have to use a certain server and all that stuff.
Yes. What's
Okay.
Bridgeport? Is that your project? That's your project?
Yes. I'm gonna talk about it.
All right, fine.
Yeah.
I'll talk about it next week. It's not quite ready yet, but I hope by then it will be. I'm gonna have some things coming out pretty quick. So.
Okay,
I mean, we don't want to
Gentlemen.
go back and have all the same problems we already have with the non-blockchain systems all over again, and we'll know back where we started, because there's
Yeah.
so much dependence on non-blockchain, non-miner machines like we're having. So it's becoming bad news, if you ask me, but okay.
okay, sounds a good place to end this episode. And sounds Ty, you want to do the next episode? Just do like a brief block. Okay, David, yeah, that would be good. All right, guys. Any quick closing thoughts? It's just wave.
Nope, that was fun.
Okay. Okay, yeah. This.
All right, guys,
that's
I'll talk to
fun.
you guys next week.
Okay, guys.
right.
Okay, have a good
Bye.
weekend, guys. See you next time.
Yeah,
Okay,
likewise.
see you everyone.
Bye.
Bye.
Bye bye.
Bye bye.